Hello and welcome to Software Architecture course. In this lecture, we will talk about another important quality attribute called modifiability. We will understand what is modifiability of a software and what are the issues that are related to modifiability, why should it be made modifiable and why and when it should not be made modifiable, and what are the tactics that as an architect you should take to make a system modifiable. So let's first look at what is meant by modifiability. So modifiability, in fact, system modification is a term that most of you have already encountered, or you have used it in some form or the other. So, but let's look at its definition first. So modifiability means that it is an ability to modify the system based on the change in the requirement so that the time and cost to implement is optimal. Impact of modification such as testing, deployment and change management is also minimal. So modification of a system is a part of our everyday life in software development, and also everybody wants that the modification to be done fast, and also everybody wants that time and cost should be optimal. So those are all desired properties. But just because someone desires it and everybody else desires it, it does not make a system modifiable. So let us pause for a minute and then essentially relook at the definition of modifiability. Modifiability means it's not an intent to change, or it's not an intent to modify. It's about how flexible, how easy the software is, so that a modification is possible for a change in requirements, so that these two things are satisfied. One is time and cost, and second is impact of modification should be less. Both are important because time and one can basically employ many people with a very low cost to reduce time and cost. But that's not the only thing. The second part is important, that impact is very important, and impact is not really dependent on people per se. Impact is dependent on the software, the way the software is designed. So when do you want to introduce modifiability? In fact, or in other words, what do you look for when you are looking for modification? So ideally, if the system has a good modifiability feature in it, this particular relationship should hold. Let me explain what this relationship means. So suppose you have a software which has been designed not with flexibility in mind, not with change modification in mind. It has just been developed in a I would say ad hoc manner. Then what happens is that later on, when and you do nothing with the software, the software runs, and then one fine day there is a change in the requirement that comes, and the change in the requirement requires you to modify the code. So that modification in the code requires obviously some effort, it requires some time, some cost. So cost of modification is that what I'm talking about. So you have a system and there is a modification request, you are modifying it and you're evaluating the cost of modification. That's very easy to compute, and in fact most of the organizations, software development organizations, software services organizations, they all know how to compute the cost of modification. So cost of modification without modifiability mechanism in place, what that means is that the software has been written without modifiability in mind. It's just written in an ad hoc manner, and a change request comes, and the change request is executed by looking at the extent of the change, modifying the code, doing the testing, deployment, change management, and so on. So that's the cost of modification without modifiability mechanism in place. Now, if you design the same system with modifiability in mind, so that you spend quite a bit of time in actually doing the modifiability in place. So the same software, but this time you have designed it in a different way. You have kept the modifiability in mind, and when you design a system keeping modifiability in mind, obviously you will have to have some overhead. That overhead would be in terms of complexity in design. There might be some additional component that you have to use so as to make it modifiable. So that would require the cost of installation of those extra modules. So essentially what happens is that when the change request comes, then in your new system, which has been designed with modifiability in mind, the cost of modification, so here the cost of modification is the cost of modification with modifiability in place. So your new system has modifiability in place, and cost of modification is to change such a system, plus cost of installing the mechanism. In fact, cost of installing that mechanism would be just a one time. So ideally, if your system is modifiable, then the cost of modification with modifiability in place plus the cost of installation should definitely be less than the cost of modification without modifiability. If if that's not the case, then the whole purpose of modifiability is defeated. In other words, if your system is modifiable, then you should be able to introduce a change much faster than a system which does not have such modifiable design. Now let's look at different modifiability scenarios. Again, these modifiability scenarios are essentially the change requirements or modifiability requirements that comes from the user, and then you as an architect are capturing those requirements in a more structured manner, more unambiguous manner. Following the same structure, who is a person who is asking for such a change? In the modifiability case, it is basically the developer, or it could be end user, or it could be system administrator. Any of them can be and any of them could initiate such a request. In this example, it is the developer. Hello? Yes? This is who? Oh, hi Nithi. Actually, I'm in a class right now. So, can you meet me at 3 o'clock? Or maybe, can you meet me at 3:15? Oh, okay. Actually, the problem is that my class is till 3 o'clock. So I can't come out at 3. I'll take some time. So 3:15. So, but till what time your placement thing go? So I'm okay to meet after 6:30. Yeah, actually send me a SMS. Send me SMS. That will be better. Yeah. Okay. Bye. Let me start. I'll start. So now let's look at modifiability scenarios. And modifiability scenarios, as you know, are essentially a way to capture the requirement related to modifiability, related to change requests, and using this template, as before, you as an architect, you are going to capture various modifiability requirements that are coming from the user, and you are capturing that in an unambiguous manner. So to begin with, you have to find out who is initiating this change, this request, or this requirement. So in this case, who could be end user or developer or system admin? Below this box who, there is an example. We are illustrating that with a developer. So essentially, though there are three possibilities in this example, we are saying that maybe the developer is initiating the request. What could be the stimulus? Remember that we are using the same template for all the quality requirements, so we are using the same terminology. So in this case, the stimulus is that these initiators actually are the actors. They want to modify functionality. Maybe they want to add a functionality, they want to modify a functionality, maybe they want to delete a functionality, or they want to modify the quality attribute. For example, they want to modify the capacity. So these are all modifiability requirements. In this example, the developer is trying to change the UI. Now, using the same template, then this stimulus is applied to the system, and the impacted part is the UI platform or the system, and this impact can happen when the system is running, or the impact can happen when the system is being compiled. The impact can take place during the design. The impact can be felt during the build time also. So at all possible places, depending on the type of change request, such impact can be observed. In this particular example, when the developer is trying to change the UI, so what is getting impacted is the code, the environment, which is the design time. So the artifact that's getting impacted is some part of the code, and the environment is design time change. What is a mitigating action? So the mitigating action is that when the fault occurs, the system should do one or more of either locate, which is impact analysis, or modify, or test, or deploy it again. Remember, we are talking about a modifiability. So modifiability is the ability of the system to absorb the change request fast. So as a result, when a developer is trying to change the UI and trying to change the code to make the change, the action is that unit test is done in this example, and the possible mitigating actions are, one is locating the point of the artifact where the change has to be made, or modifiability has to be introduced, or it could be even modification, it could be testing, it could be deployed again. Any of these are possible actions. In this example, the possible action being taken is a unit testing done. And what are the measurable responses? The responses are the volume of the impact because of the change request, the cost of modification, it could be time and effort, extent of the impact to the other system because of the change, or new defects that are introduced. So if we follow this example, the developer is trying to change the UI, the artifact is code, the action is that unit testing is done, and this whole exercise is done in 4 hours. So in this case, the time and effort would be 4 hours by one person. Now let's look at different modifiability tactics that would enable an architect or a designer to introduce modifiability into the system. So modifiability being the root of this tactics tree, these are the following high-level tactics that one need to look into. One is to increase the cohesion. Then the second is to reduce the coupling. The third is defer binding. Let's look at this cohesion, coupling, and defer binding in more detail. So to increase the cohesion, one need to look at factoring of common services. One need to anticipate the change and take the action accordingly. One need to generalize a module as much as possible so that it can absorb the change, or it can also limit the possible options so that it doesn't even create a scenario of things being modified. In the reduced coupling case, the possible tactics could be hiding of information. Another could be maintaining an existing interface. Another tactic could be restrict the communication paths and various dependencies. And fourth one could be using of intermediary between different modules. Defer binding would basically say that defer the binding at the compile time or defer binding at the runtime. Under the compile time, essentially one could do a component replacement. Under the runtime, it could be runtime registration techniques. Component replacement is nothing but the tricks that many people use in Unix in Makefile. Runtime could also mean that changing things using configuration files, or using object-oriented polymorphism, or even using some kind of a dynamic lookup of the services. Plugin is also another technique which is very runtime to basically add, modify certain features. Publish and subscribe is also another technique. Now let's look at all these features in details, all these tactics in detail. To look at these tactics in detail, we need to first understand the dependency between modules and what kind of dependencies that might exist. So to explain that, I have used a notation B arrow A. That means that module B is dependent on A. And now let us see that what are the possible dependencies that exist. One could be the syntax type dependency, which can occur during compiler or runtime, and this can happen at the level of data, or it can happen at the level of service. So at the level of data, the dependency is that B is using some type or format of the data that's created by A. So in that sense, B is somehow getting dependent on A. B can use a service of A. Maybe B is using the API provided by A. That could be another dependency type. It is syntactic because it is detected during compile time. Semantics of A is another way of another type of dependency. Here there could be data semantics or there could be service semantics. They are more or less the same, but let's look at this. So data semantics means that B makes some assumption and B is using some data that's created by A, and that data has a certain semantics. There could be some data structure in which in that data structure there are certain fields, and that field might contain some values, and that value has some meaning. There could be some numbers, and those numbers might have some meaning. Now, so those meanings are all assumed meanings. There is no and those assumptions are made by B because B is using the data created by A. Now so here the dependency is a bit quite tricky, because A is creating the data and A is putting those data values, and A is assuming certain meaning to those data values, and B is also interpreting those data values with some meaning. Those meanings should be consistent. If it is not, then there is a problem. Then there is a sequence dependency. Sequence dependency is that the data packets that are created by A must be in the same order as understood by B. So this is typically the case in case of streaming of packets data in different packet transmission protocols. Such things are very common and very relevant. So A is streaming some data and B is consuming that, and there is a meaning of those streams. They are not just unordered, they are ordered stream. Therefore the ordering semantics of that is generated by A should be also understood by B. For example, A might just send the header first, and B also but if B assumes that there is no header, then there is a problem. Control sequence is that A must execute, let us say, 5 milliseconds before B, and there could be some scenarios that unless A is executed 5 milliseconds before B, execution of B is going to be wrong. So that creates a dependency between A and B. In fact, B would be dependent on A in that sense. Or on an API of A can be called by B only after calling some other APIs. That's also a sequence kind of a dependency. Interface identity is also another type of dependency where the handle of A must be consistent with B, and specifically when A is maintaining multiple interfaces. So in that case, when B is using a handle of A, so that handle it will essentially be some kind of interface, and that interface must be consistent. Location of A is also another important dependency. B may assume that A is in process or in a different process or even in a different hardware. Now such an assumption creates a location dependency on A. Now if B assumes that A is always in process, then and then if you plan to move A from in process to out of process, then this whole system will break. Quality of service or the data provided by A is also another type of dependency where the data quality produced by A must be greater than some accuracy for B to work. Now these kind of things are happening in case of sensor networks or more real-time systems, embedded systems, where a certain data quality must be ensured by A, only then B can work. Existence of A is also very interesting dependency between B and A. Here B is dependent on A. B is assuming that A must exist when B is calling A, and if that assumption is not valid, then the whole program might crash. This is a very common example of people making mistakes of not creating an object and then trying to reference to that object, and that creating kind of a null pointer exception. Resource behavior of A is also another type of dependency. B may assume that both are going to use the same memory location, but if that's violated, then B will be in trouble. B needs to reserve a resource that is owned by A, and if that's the assumption, then that creates B to be dependent on A, and if such a reservation request is not met or for some reason this is gone, then B will not be able to function properly. So these are the possible types of dependencies that can exist between two modules, B and A. Now what are the tactics that one can actually use to really address different modifiability related requirements? One is, as we said, the factoring of common services. What does it mean is that if you find that a particular service is being used by many modules, and you factor it out and then call that as a common service, and the common service is basically is rendered through a specialized module, and so that if this common service is impacted, or if the common service is changed, then only that implementing module will be impacted, not the other systems. Typically these are used in application framework and middleware, this kind of techniques, so that your code is not impacted. You can always use your code, and you can use different versions of the middleware. It definitely reduces coupling and increases the cohesion. Anticipate expected changes. That's actually a bit difficult. In fact, it is quite difficult to anticipate what kind of changes might be there. Therefore, this anticipation, and in fact these tactics, should be actually coupled with factoring of common services. So if more you do factoring, then it will be possible to if not anticipate, but at least any unanticipated changes and its impact would be much more restricted if you actually use factoring of common service. Very important thing is that allow extension points to accommodate changes. This is one of the very well-known techniques in modern designs, where no one knows what kind of changes might come. Therefore, they allow different extension points so that one can add new features. Module generalization is allowing it to perform broader range of functions. That requires quite a bit of design effort, and externalize various configuration parameters, for example using XML and things like that. And a module reconfigures itself based on the configurable parameters. So that way changes are absorbed at runtime. So changes are not really those changes will not impact the module to be changed and to be modified. Actually, one can just do it with the same version of the module. The module can just read the new configuration parameter. Externalize the business rules is also another technique by which the module can be generalized, and therefore changes can be done only at the business rule level. Limit possible options. Do not keep too many options for a module, or you even do not keep too many options to do the same thing. That makes life complicated, and really that does not add any value. In fact, that creates more problem in terms of maintainability. So this example is module B is calling module A, and then there is a call or dependency between module B and module A. In fact, module B is dependent on module A in this example. Let's look at the next tactics, which is prevention of ripple effect. This prevention of ripple effect, this particular tactic is hiding of information of A, obviously, because B is dependent on A in our example. So B depends on A, so we are hiding information of A. Use of interfaces. Allow only published API based calls. Do not allow any random kind of call. Then maintain existing interface of A. What that means is that A's interface, whatever it is, should not be changed. You can change its implementation, but do not change the interface. If required, add new interfaces. Use wrappers or adapters so that the interfaces are not changed, because changing of interface can have real impact on many systems. Use of stub is also advisable. Restrict the communication path is, if too many modules are dependent on A, then this needs to be restricted from the modifiability point of view. If too many modules are dependent on A, then if A is modified, many people will be impacted. Use of intermediary between B and A is a common tactic with respect to data. So one can use a repository from which B can read the data and A can create the data and put that in the repository. This is called blackboard pattern, and we will learn blackboard pattern later on in the architectural pattern class. Then another technique is called the publish and subscribe, where the data is flowing through a central hub. This is also another pattern that we will learn during architecture pattern. We will also learn the same thing during design pattern. MVC pattern is also another technique. Now, with respect to service, use of design patterns like bridge, mediator, strategy, proxy, such kind of design patterns can actually help putting an intermediary between B and A. Identity of A, one can use a broker pattern which deals with A's identity. Now if you use a broker pattern, it's again an architecture pattern. We will learn that later on. That will actually help in identifying identity of A. Location of A can be made general and not hard coded in the code if you are using naming service. So naming service can be used to discover A, so one need not really put a hard coded object creation. Existence of A, one can use a factory pattern to basically make sure that if the A is not existing, one can always create the object. So in this example, module B calls depends on or uses the module A. Deferring of binding time, let's look at this. Here we are talking about a runtime registration of A. So it's more of a plug and play. A is registered only at the runtime as opposed to during compile time, and use of publish and subscribe is a mechanism where runtime registration is used quite frequently. Configuration of files or configuration files, sorry, not configuration of files, it's configuration files. So configuration files are very common techniques to defer the binding in some sense, because what happens is that configuration files are external files in which the users put different configuration parameters which are read by the system at runtime, and by reading those configuration parameters the system retunes itself or configures itself. So that's this is definitely, in a sense, it is deferring different types of binding, and this binding is not happening at the coding time or design time or compile time or even linking time. It's happening really at the runtime. Polymorphism is a well-known object-oriented technique in which you are calling the right object's method at runtime only. It is also late binding of method call. Replacement of component for A during load time. So what happens is that in Java, for example, one can use, or even it is true in .NET, there are class loader module which basically loads a class, and using the class loader module, really the component loading is deferred at runtime. It is really not done at compile time. So if someone uses a class loader to load a class, then one can actually choose different versions of a particular class, and therefore if a particular version, one can replace old version with a new version. Such things are possible if a class loader mechanism is used to load the class, and that can definitely help in component replacement easily. Adherence to a defined protocol or runtime binding of independent processes is also another technique by which the binding time can be impacted and binding time really can be deferred. In this case also the module B is calling module A, and then the dependencies could be called depends on or uses. Let's look at different design checklists for modifiability. If you remember, we introduced different design checklist categories. We are going to elaborate those categories with respect to modifiability. First is allocation of responsibility. So let us see that what it means in the context of modifiability. When you are talking about allocation of responsibilities to different components of the system, first you need to determine the type of changes that can come due to either technical reasons, due to customer requirements, or due to business. That can come means that anticipate what are the type of changes that can happen later on. This definitely requires an experience. This definitely requires interaction with the users, and obviously essentially the combination of these two can give insight that in this system what are the features that is more susceptible to the change. And also determine what sort of additional features are required to handle the change. Determine which existing features are going to be impacted by the change. So this change, when it comes, it can demand for additional features, or it can impact existing features. Now, after determining all this, the design of those features, design of those modules or components must take such kind of change request kind of things into account. Must be designed in such a way that it can handle impact of its feature, or it can handle if a new feature is created. It can handle means that it should be able to handle with minimal impact on the rest of the system. The design should be done in such a way. But, it can be done only if you first find out what are the modules that should be touched, should be modified, should be designed keeping modifiability in mind. Now the next one is called coordination model. Coordination model is essentially talking about coordination, interaction between different components. For those where modifiability is a concern, use techniques to reduce the coupling. This is always a well-known practice, to reduce the coupling between modules, specifically where that these modules are going to be modified. Use of publish and subscribe, use of enterprise service bus are common techniques to essentially achieve this. Identify which features can change at runtime. Identify which devices, communication protocols, or communication paths can change at runtime. And make sure that such changes have limited impact on the system. Very important that identify which features can change at runtime, or which devices, communication paths, etc. can change at runtime, and do your design in that appropriately, so that if those devices change or the communication paths change, it shouldn't be impacted. One very simple example is that you might write a program where you assume that your data will be available in a particular location in the hard disk. Now, if this program is moved from your computer to somebody else's computer, such as the assumption is broken, and therefore while making the code, while doing the design, you need to identify that this particular path, communication path, or this particular file path that you are assuming, it can undergo change later on, and keeping that in mind, you need to design it properly. Let's look at the design checklist, a few more design checklists for modifiability. About the data model. Now again, identify for anticipated changes what are the data elements that will be impacted and what are the nature of impact. For example, will it be a new creation of data, or creation of new type of data, or existing data? Would that be modified? If that is modified, to what extent it is going to be modified? Will it be deleted? Is it required to persist the data which was not persisted earlier? Is it necessary to translate the data in order to process it later on? So such kind of changes one needs to analyze. And one general tactic is that while doing the design, try to group the elements, the data elements that are likely to change together. This often helps in containing the effect, or containing the impact of the change to a small subset. Design to ensure that the changes have minimal impact to the rest of the system. In fact, grouping of the data is a good tactic here. Resource management with respect to modifiability. So determine how addition, deletion, or modification of a feature or a quality attribute can cause new resources to be used, or is going to impact the resource usage, or it can change resource usage limits. So these two things must be analyzed, that whether an addition or deletion of features can cause a new resource to be added or existing resource limit to be impacted, and ensure that the resources after modification are sufficient to meet the system requirement. If there is a change requirement come or change request comes, which after implementation have a massive impact on CPU usage, then it is a problem. Now this is a very common phenomenon, that a change request comes, and that when that is implemented it works fine, but when it is put in the data center or it is put in the runtime environment, one finds that suddenly the CPU usage has gone up, or suddenly the memory usage has gone up. So the changes that causes such resource usage to go up must be analyzed before, and in fact must be looked at properly. In fact, at no point in time you can have a scenario where after modification, after adding new features, for example, that resource consumption is exceeding the limits. One practice is to basically create something like a resource manager module that captures different resource usage policies, so that all these policy rules can be encoded inside the resource manager. Let's look at the binding. Binding, again, for modifiability, late binding is a mantra here. Determine the latest time at which the anticipated change is required, and basically do the needful. So by determine the latest time at which the anticipated change is required, by that it means that you see that how far you can delay where you can run the system without introducing the change. Example could be that, let us say you are actually using certain feature of A, you are modifying certain feature of A, you analyze that to what extent the system can run without using this modified feature of A. Then you know that what is the time when this modified feature of A is going to be used. So till that time when a modified feature of A is not going to be used, make sure that your design does not really start invoking A at all. So choose defer binding if possible, and also try to avoid too many binding choices. That makes the life really complicated, and that makes architecture complicated, and analysis of the system quite complicated. So try to avoid too many binding choices. Make it simple. Choice of technology is a very important factor in modifiability. Evaluate the technology that can handle modification with least impact. For example, you can adopt enterprise service bus. For example, you can use certain frameworks so as to handle, let us say, object relational mapping easily. For examples like Hibernate, which can basically connect the relational database with your system, and that is a nice framework which can absorb a lot of change, and in fact it's a very good example of modifiability, that your code is not changing, you can basically change the structure in the Hibernate itself. But using such technology, using such frameworks can have a vendor lock-in problem. So as an architect, you need to first understand whether vendor lock-in is okay or not, and to what extent it is okay, and take the decision while choosing the right technology. Thank you.